Hello all, welcome back to Triple tutorial channel. Here in this video, we are going to discuss about the need of WHEATSTONE Bridge and its construction and working. So we will discuss about it, okay. So here you can see the basic circuit setup for the WHEATSTONE Bridge. Generally, WHEATSTONE Bridge can be used for the measurement of medium resistance, okay. It can be used for the measurement of medium resistance. Medium resistance means the resistance value will ranging from 1 ohm to 100 kilo ohm. This is the general range for the medium resistance. Okay. So let us go through on the circuit setup for the WHEATSTONE bridge. Here it consists of mainly 4 amps. AB, BC. Here in this diagram it is AB, BC, CD and AD. In each amps you can see each amp consists of one resistor. So here 4 amps, so there will be 4 resistors. In amp AB there will be a resistor that is marked as P, and for amp BC it consists of the resistor which is Q, and for CD it consists of S, and for the amp AD that consists of resistor R. Because of the presence of these 4 amps, we can say WHEATSTONE bridge is also known as a resistance bridge. Okay. It is also known as a resistance bridge. So resistance bridge is the another name for the WHEATSTONE bridge. So here generally we are finding the value of unknown resistor. Here you can see 4 resistors. P, Q are the known values of resistors, and for the resistor S, that is the variable resistors, and for the resistor R, that is the unknown resistor. Okay. So we have to find the value of the unknown resistor R by comparing it with the other resistors. So simply we can define the WHEATSTONE bridge like it is a bridge, or it is a simple circuit that can be used for finding the unknown value of resistance by comparing it with the known resistors. Okay. Used for finding. Okay. Used for finding. Okay. This is we can say this is a basic definition for the WHEATSTONE bridge. Simple definition for the WHEATSTONE bridge. So here R is the unknown resistor. So we have to find the value of the resistor R by comparing it with the P, Q and S. So this is the basic requirement. Okay, in addition to that, we are giving a supply source in between the amps A and between the terminals A and C, and there will be a galvanometer in between the terminals B and D. So the function of the galvanometer is to indicate the flow of current through this section. Okay. WHEATSTONE bridge is applicable only when the circuit is at balanced condition. This is the basic requirements for the WHEATSTONE bridge. Okay. Only when the circuit is balanced, it will be applicable. At the balanced condition, the voltage across the terminals A and B must be equal to the voltage across the terminal A and D, and also voltage across the terminal VBC must be equal to the voltage across the terminal C and D. So to make the circuit balanced, we are adjusting the variable resistor, and thereby the circuit will be balanced. Normal condition it will be in unbalanced condition. To make it balanced, we are adjusting the variable resistor, and thereby we will get the deflection of the galvanometer as 0. Generally it is working as the null deflection principle. Okay, null deflection principle. Okay, so when the bridge is balanced, at that time the voltage across the terminal AB and AD will be equal. So we can write that at the balanced condition, voltage across the terminal, I can write it as AB, voltage across the terminal AB must be equal to the voltage across the terminal AD, and I can write at that time, at the same time, the voltage across the terminal VBC must be equal to the voltage across the terminal VCD. Okay, so when we are giving a supply, the current will flow from this point through this, so it is marked as I1, and from this point generally current will flow from here to this point, and at the point A it will be get splitted into two. One is I1 and the other one is I2. So when the bridge is balanced, okay, I4 can mark like this. Okay, there is a mistake. Okay, this is the correct way. So when the bridge is balanced, at that condition, no current will flow through the circuit B and D. This is the balanced condition. So that means at balanced condition, I1 will be equal to, I can say I1 will be equal to I3, and in the same way I can write I2 will be same as that of I4. Okay. So VAB. So what will be the voltage across VAB? I can write it as, based on Ohm's law, I can write VAB is I1P. And what will be the voltage across VAD? It will be I2R. Okay, I2R. This will be the equation number 1. And what will be the voltage across the terminal VBC? It is I3Q, which will be equal to I4S. This will be the equation number 2. So at balanced condition, I1 will be equal to I3 and I2 will be equal to I4. We have to remember this point. Okay. At balanced condition, there will be no current flows through this point, through the galvanometer. It will show null deflection. So I can say I1 will flow through the amp Q. That means I1 will be equal to I3. In the same way, I2 will be equal to I4 because of the balanced condition of the bridge. Okay. So when I divide equation number 1 by equation number 2, then I can write I1P divided by I3Q, which is equal to I2R divided by I4S. So when I put the substitutions for I1 as I3 and I2 as I4, then I can write, I am considering instead of I3, I am considering I1. Okay, so I can write the equation here as I1P divided by I1Q, which will be equal to I2R divided by, instead of I4 I can write I2, or otherwise you can write, instead of I2 you can write I4. Okay, whatever you can write. So I2S, both the terms will cancel each other. Here I1 and I1 will cancel each other, and here I2 and I2. So we will get P by Q, which is equal to R by S. So we have to find the value of unknown resistance, which is R. So I can write R is equal to PS divided by Q. This will be the final expressions to find the value of unknown resistor R. Okay, by comparing it with the known values of resistance. So this is the basic construction and working and the derivation for finding the unknown resistance of the circuit. Okay, it has one disadvantage because it is normally used for low or medium values of the resistance. So we cannot measure the circuit to measure high value of high value. Okay, that is the major disadvantage for the Wheatstone's bridge. But the value of the unknown resistance will be very accurate and it is a sensitive device. Okay, so this is the major explanation for the Wheatstone's bridge. Okay, so thank you.